What's up, everybody? It's Hutch here, and this is Module 11, Lesson 6, all about scale and scale drawings and scale factor. So let's check this out. This is all about using a ratio and proportions, and also just your understanding of what a multiplier is from X to Y, inputs, outputs, that kind of thing. So let's go ahead and take a look at this. You're very familiar with scale drawings, scale models. Maybe you've seen the flagship Niagara. They might have a model of the flagship Niagara, which is, of course, smaller than it actually is, or a scale drawing on a map with the units and things like that. Okay, so what I want you to remember is anytime we are, predicting a larger amount, a smaller amount, or whatever, remember with it we use proportions to do that. Okay, and the important thing with this is that if you have one unit is actually 200 feet and you're making your prediction, so then you'd be wondering, well, what would 4 units be, how many actual feet, that kind of thing. And so you can cross multiply or find the multiplier to create that proportion and solve that proportion. All right, so let's take a look at example 1. Here's the map. We're talking about from Hagerstown to Annapolis. Let me get the pen out again. We get our straight line. So we're talking about this distance right here from Hagerstown to Annapolis in Maryland. We don't have to measure that out. We do see the scale here is every unit is 24 miles. Okay, and normally you would have to sort of measure that out, but we don't have to because they're letting us know that the distance is 4 units. So we don't even have to grab a ruler out for this one. Okay, it says write an equation involving equivalent ratios using the scale as one of the ratios. Okay, so all we do, remember, set it up. Here's the scale is 24 miles is 1 unit, or we can flip-flop it. It really doesn't matter as long as you know that you have the same numerators, same denominators. So I could say 24 miles is 1 unit. So create my proportion. So my question is, well, how much would 4 units be, right? Well, and where does the units need to be? It needs to be in the denominator for this one, so it matches. Okay, so let's go ahead and list that. And then this, of course, would be X. Now, for these ones, anytime we're dealing with unit rates, remember, out of 1, it's really easy to find the multiplier. We're just multiplying times 4 over 4, and we're going to easily get our X value here. We don't have to cross multiply for this one because it's a nice and easy multiplier. So 24 times 4 is 96, and then we need to make sure you include your labels. So 96 miles is 4 units. Okay, so there we go, and we can go ahead and answer the question, what is the actual distance between cities? They actually wanted us to use D, so I'm going to go ahead and follow those directions and use D for distance, and we can go ahead and say D equals 96 miles and circle our answer. All right, go ahead and try this one if you want to pause or follow along. It's up to you. We have the actual distance is 1.5 units from Akron to Cleveland. So I'm going to go ahead and represent that there. Let's look at what our unit rate is. And so we need to create our proportion, right? This time I'll do it the other way around. I'll go ahead and do 1 unit on top over 20 miles, just so you can see that it works both ways. Set it equal to what is the distance we have? Well, it's 1.5 units. So now units is on top. So I need to go ahead and put that. I'm just going to do 1.5 because it's going to be easier to work with. So 1.5 units, and so we have distance, or I can just use X since they're not telling me what I have to use. So easy multiplier because we have a unit rate technically. So times 1.5 over 1.5, and that's going to solve X for us. So 20 times 1.5 gets us 30 miles. Okay, so what is the actual distance between the cities? Now we have to actually write the actual distance is 30 miles. Okay, and there we go with our official answer. All right, now let's go ahead and use scale drawings to find the area. So blueprints are really common space where you'll see this kind of stuff. This is a good example of one that you're going to see on the test. You're going to have to look at a blueprint and calculate the actual area. Okay, so this drawing shows the map of a restaurant drawn to scale. 1 inch represents 5 feet. So you want to right away find the scale. And so we know that our ratio that we're going to be using is 1 inch is 5 feet. And you can write it with the inch on top or on the bottom, doesn't matter, but you just know with your proportion, you need to make them match. So the question then is, what is the actual area of the kitchen? And they're letting you know a kitchen's a rectangle, and we know that we do length times width to find the area. Okay, and so we have the length and the width. So you're going to have to sort of separate this out. So let's have this be my length work, this be my width work. And so I have to set up 2 proportion problems real quick. And some of these are easy, just multiplication problems, if we're being honest. You might be able to look at that and just be like, oh, 1 inch is 5 feet. So obviously, if there's 5 inches, that's 5 times 5. And you'd be right. You could, another way to show your work would just be to show 5 times 5 is 25, and the 5 times 9 is the 45, and get your answer, and that's fine also. We're going to be doing the same thing here, just in proportion form. Okay, so for my length, length is typically your long side. So instead of 1 inch, I have 9 inches. And so I'm wondering how much that is. And then instead of so 1 inch is 5 feet. And then instead of the 1 inch for the width, I have 5 inches. Okay. And so we're wondering what our x is for both of these. Okay. All right. So 1 inch is 5 feet. So what are we going to, if we have 9 inches, how many feet do we have? So let's go ahead and do our multiplier here. So this is times 9 over 9. This one's times 5 over 5. And you can see we have 5 times 9 is 45 feet for the top. 5 times 5 is 25 feet here. Okay, so our length is 45 feet and our width is 25 feet. Okay, and I'm going to go ahead and now do our area formula. Okay, so we found the actual length of the kitchen. Okay, and we can just sort of tag that here. We found the actual width of the kitchen right there. Now we need to go ahead and find the actual area. So we have a length and a width. So what's the area formula? Area equals length times width. And so area equals, our length was 45, width was 25. So we have 45 times 25. And so area equals 45 times 25 equals 1,125. So the part that you're going to lose points on, though, is if you forget to put units squared. And this is feet. And you need to make sure you put feet squared. Don't write squared feet. That's not accurate. That would be taking the number and squaring it. Okay. Make sure you do feet with the mini 2. Okay. And there's your official answer. All right, let's go ahead and go to example 2. Right away, I found the scale. 1 inch is 3 feet. What is the actual area of the bedroom? So we're looking at bedroom 3 here. There we go. So let's go ahead and find bedroom 3. So here it is here, our length and width. Okay, we have 4.5 inches and 3 inches. So we know 1 inch is 3 feet. Let's go ahead and use just our strategy. Since we have a unit rate, we know every inch is 3 feet. So that means that we also could set it up as a proportion, or I just know, well, if every inch, each inch is 3 feet, I can just multiply by 3 and get my new amount here, and I can multiply by 3 and get my new amount here, okay? So you can use common sense. There's lots of ways to get to a solution, and this doesn't say I have to use a proportion. So let's go ahead and do our 3 times 4.5 for here. And we get 13.5 feet. And our 3 times 3 is 9 feet. Okay, so those are just our distances. They're not in feet squared. We need to find the actual length and actual width. So our actual length was 13.5 feet. Our actual width is 9 feet. So what is the area? Well, our area formula is length times width. So our area equals 13.5 times 9. And so what is that in feet squared? 13.5 times 9 is 121.5, and we need to make sure we put feet squared, and there we go. Okay, so that's the actual area of that. Now the check is, what about bedroom 1? So you can pause and do that on your own. Here's my length and my width. And so I'd always recommend look down below. This is the same size here. So we have 3, and there's a little inches. Inches is the tick marks, and a single is feet. Okay, so quotation mark is inches, single quote is feet. All right, so it's still the same scale. So times 3 times 3. Go ahead and try that on your own if you want. We have times 3 times 3. So this is 9 feet. And we have 3 1/4, or 3.25. Times 3 is 9.75. Okay, feet. All right, so let's go ahead and multiply those out. I do want to show our work down below, so let's go ahead and write our area equals length times width, so we can at least just put the 9.75 times the 9 and write what the area is. Okay, so 9.75 times 9, and we get an area of 87.75 feet squared. Make sure you have that. We don't want to lose points. All right, reproducing scale drawings. So we can look at this a couple ways. Let's go ahead and tackle this. Basically, we have a scale drawing, and it is in the scale of 1 unit equals 30 meters. Okay, so that's your ratio, is 1 to 30. Okay, 1 unit equals 30 actual meters. They want you to reproduce the drawing with a scale of 1 unit to 10 meters. So they want you to change the scale for this. Okay, so what you have to notice right now is how many units exist in this right now. So right now we have 1, 2, 3, 4 units. And we have 1.5 units. So 1.5 units. Okay, so what is that actually as meters? Okay, so as meters, well, every unit is 30 meters. So you could set up a proportion, or we know that if every unit is 30 meters, that's multiplication. We could just say times 30 and times 30, and we can find out how many meters this is. So 3 times 4 is 12, with the extra 0 is 120 meters. Okay, and then 30 times 1.5 is 45 meters. Okay, so there's our information of our current drawing. Okay, we want to go ahead and change this now so that it fits our new scale. So we want to change it so that 1 unit is 10 meters instead. Okay, so let's go ahead and see what you would do to get from 10 meters to 30 meters. Okay, so let's see. So from 10, what would you multiply by to get to 30? Well, 10, 20, 30. We would multiply by 3. So we're changing the scale, okay, by this what's called a scale factor of 3, okay, because we're going creating the situation where we were at 1 unit is 30 meters to a unit is 10 meters. And so our picture is actually going to get bigger, okay? So let's go ahead and take a look at how this would work, okay? So if we're multiplying it by 3, that's the sort of change in things, Okay, let's go ahead and see what that would look like. Okay, so instead of 4 units, I'm multiplying it by 3, and 4 times 3 would be 12 units. So I need to make something 12 units in length, and then instead of 1.5, what's 1.5 times 3? Would be 4.5 units. Okay, so let's go ahead and see what that would look like, and we'll draw it over top. Okay, so let's go over 12. Okay, so 1, 2, well, I can just make my big line and hold it. And then I can move it 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I need to go up 4.5. So we'll just go on the side first, lock it in there, and then we can go 1, 2, 3, 4.5. And there we go. Okay, let's go ahead and reproduce that on the other side. Lock it in, 1, 2, 3, 4.5. And then we can go straight across. Just make your line, lock it in, and then you can adjust. All right, so there we go. We reproduced it. So 1 unit is 10 meters now instead. Okay, and so let's go ahead and look at what we created here. Okay, if 1 unit is 10 meters, then what do we have? Well, now we have 120 meters here, and we have 10 times 4.5, okay, swoop, and we have 45 meters. Okay, so you can see we still have the 120 meters and we still have the 45 meters. We just changed the scale of our drawing, and you can see why it ended up being a multiplier of times 3, because our drawing is actually bigger, because each unit is only 10 meters instead of each unit being 30 meters. Okay, and so there we go. And if you scroll down, you can actually see a drawing that matches what we did there. Okay, so you have to sort of just think through that and think logically. All right, let's get to your apply now, and then you can get to your practice with this. Okay, William is laying new flooring in a storage shed. The blueprint shows a scale of, so let's highlight that or underline it. And then we have building material that's that amount per square foot. Okay, how much will it cost? So here's the question I need to answer for the new flooring, round to the nearest cent. So just normal money. Okay, all right. So first we need to calculate the actual square footage of that space, and then we can calculate how much it'll cost. Okay, so we have 1 inch equals 3 feet. So again, we could set up a proportion if you like to do it that way. Okay, where you say, well, if every 3 feet is an inch, how many inches do I have? Well, I have 2 1/4 inch, and it'll tell me how many feet, right? So we could do it that way, or if you just understand that every inch is 3 feet, it's a nice unit rate, so you have your multiplier. So this is just times 3, and it's going to tell you how many feet that is, because every inch is 3 feet. So that's really the quickest way. Let's just go ahead and do 2.25 times 3, and I'm going to rewrite what this is now. So 6.75 feet and 3.75, that's what 3/4 is. 3.75, if I can actually type it, times 3 is 11.25 feet. I'm just doing the tick mark for feet. All right, so it's $1.09 per square foot. Well, I haven't calculated square foot yet, right? I just calculated the length and the width. So I need to calculate the area, which is length times width. So 11.25 times 6.75. That'll get us our area in feet squared. So 11.25 times 6.75, and we have 75.9375 feet squared. Okay, so that's the area. Now it says how much will it cost for new flooring if it's $1.09 per square foot. Well, there's the square footage. Let's go ahead and multiply it by 1.09 and see what we get. Okay, so I'm going to show my work though. So times 109 equals, and then we're rounding to the nearest cent, and we have $82.77 because 771, if I'm cutting it there, it stays at the 7. We're rounding it to the nearest cent. All right, so how much will cost for new flooring? It will cost, and there we go. Okay. All right. I want you to go ahead and give this one a shot. Here's your scale, and the wallpaper is going to cost that much per square foot. How much will it cost to buy wallpaper for the actual wall of the living room? So this picture is the actual wall. Go ahead and pause, give it a shot, or you can follow along with me. Okay. I know every inch is 4 feet. So that's each inch is 4 feet. That's multiplication. So I can just do times 4 times 4. Okay. If it was something like 2 inches is 4 feet, you could find the unit rate first and then use that multiplier or just create your proportion. It's up to you. Okay. But I like just keeping it simple if it is simple, which it is with these. 3.5 times 4 equals 14 feet. And then 2.25 times 4 equals 9 feet. Okay. How do I find the square footage? Well, square foot is area. So area equals length times width, 14 times 9. And so what is the area? Well, 9 times 14 is 126. And how do we not lose a point? We write units squared, which in this case is feet. Okay. Now it's $1.79 per square foot. So we need to continue on and multiply money now, $1.79. So how much is it going to cost? So times $1.79 equals, round to the nearest cent. And we have, how much will it cost to buy wallpaper? It will cost $225.54. And there you go. Okay. All right. The next part here that I want to talk about is a thing called scale factor. Scale factor, I'm going to really simplify this for you. It is just the multiplier. Okay, so when we're talking about how did you get from small to big, or what is the scale factor of the smaller one if you started with the big, but that's really like simply all it is what is the multiplier. So you can see like this, to get from the small to the big, if you went 3 to 6, okay, well, you multiply by 2. It's a scale factor. You doubled its size. If you went from big to small, we can look at this side and this side. You have to look at the same sides. Okay, we went from 12 to 6, so you multiplied by a half. Okay, so just focus on what is the multiplier from the one to the other. Okay, if I say though, hey, this is my small model. Okay, what is its scale factor? Okay, compared to the big, well, it's a half. Okay, of the big. So one of the things I want you to focus on is think of it as a table, first of all. Okay, you have some sort of starting value, you have a multiplier, and you end up with a final value. Okay, but I also want you to pay attention to the order and use common sense. Okay, and so it says right here, okay, if the scale of a sailboat is 1 inch is 72 inches, that means that we're using the actual sailboat to make the model sailboat. Okay, you're not going to make the big sailboat because of the model. Okay, so the model is created from the actual. So in this example, the starting value is the original sailboat. And so that's what you have to sort of think about is what are they actually asking? So in this case, the starting value is the 72-inch sailboat, okay? And if it's in feet, you're going to have to change it to inches, okay, to make it match. And then our final value is we end up with this 1-inch model, okay? So what was the scale factor? Well, we're wondering 72 inches times what gets me 1 inch. So I would just do 1 divided by 72, and it's going to be this weird thing. So you don't have to do that. You can just say times 1/72. Okay, that's what 1 divided by 72 is. Okay, so 72 inches times 1 divided by 72 is going to equal 1 inch. So the scale factor is 1/72 of the size. Okay, so that's how that would work. Okay, I want you to really think about the question and answer also. So if the question asks for the scale factor of the model itself, just think about that. Would the model be a number smaller than 1, or would it be larger than 1? Okay, if we're asking for the real size, okay, it is double the size of the model. If we're asking for the smaller size, it's going to be a smaller than 1 scale factor. So the model would have to be a smaller scale factor, like we're reducing it by a half, or reducing it by 1/72, things like that. The model's always going to be smaller, so that's going to be smaller than 1 because 1 would be equal. So let's go ahead and I want you to try it with this. So Shrinky Dinks are an art craft toy invented in 1973 by Betty Morris of Brookfield, Wisconsin. These toys reached the height of their popularity in the 1980s. Shrinky Dinks consist of thin, flexible sheets of polystyrene, which is a common polymer. A polymer is like a plastic. Prior to heating, this thin, flexible sheet can be colored and cut into shapes. And this is a lab that you're going to be doing very soon. So let's see how you do with this. So I want you to look at the original drawing, and this is just a drawing that I did on the Shrinky Dink polystyrene paper. Okay, and I want you to see, I picked 2 points, and you can see the 2 points I picked were right at the top corners of GM. Okay, and you could find the area of a circle or things like that as well, but that's our next module. So let's just pick 2 points on here. What is the distance between these 2 points? Okay, this should say TWO, by the way. All right, so we can obviously see it's 4.7 centimeters. Okay, then we put it in the oven, okay, for 2 minutes at I think it was 320 degrees or something like that. What's the new shrunken distance? Okay, and this is in centimeters. Okay, this is inches up above. We're not doing that. We're using the centimeters. So you can see from this point straight across to the new point again is how many centimeters? 2 centimeters. So we went from 4.7 centimeters down to 2 centimeters. So the question is, what is the scale factor? And so remember at the top I said, how should you think about it? I want you to think of it as a table. Okay, so what was the starting value? The starting value was 4.7. What was the final value? The final value is 2 centimeters. Okay, and they're in the same units, which is helpful. So what is the scale factor? What's the multiplier? Okay, so we're asking 4.7 times what equals 2. So to find that, we would do 2 divided by 4.7, and we would get this scale factor of, let's see, 0.4. If we cut it off here, 4.3. Okay, so about there. Okay, or you could say 2 over 4.7. Okay, so that's another option. Okay, but it gives you an idea. I like the decimal a lot because it shows you that it's about half. Okay, being 0.43, or about 2/5. Okay, because we know 1/5 is 0.2, 2/5 is 0.4. So it gives us a better idea in decimal form. Okay, so what is the scale factor? The scale factor is times approximately, so we can use that, 0.43. Okay, so that's our scale factor. So what is the percent decrease? So when we're finding percent change, all you're going to do is find the difference between the starting and final as an absolute value. We just want to know what that change is. So let's go ahead and find the actual percent decrease. Okay, because on the box, they talk about like a 20% decrease. Let's see what it actually is on here. So we went from 4.7 to 2. So what is that difference? So let's do our 4.7 minus 2, but we're going to take the absolute value of that. Okay, so what do we get? 4.7 minus 2. Okay, it's a positive anyway, so it doesn't really matter. Okay, so we have a change of 2.7, okay? And then we take that change and we divide it by the starting. So the change divided by the starting, and the starting was 4.7, okay? And let's see what we get as a decimal. So 2.7 divided by 4.7 gets us this decimal of 0.574. So let's just cut it off there, okay? And then we need to turn it into a percent. So we know a percent, we just do 2 swoops to the right, multiply by 100. So what is that as a percent? 57%, okay? Now, here's the thing, though. I want you to always write increase or decrease. So what was it? Well, that was a 57% decrease, okay? And so quite a bit more than the 20% they said on the box that I got. Okay, and so this is what you're going to be doing with yours tomorrow, which will be pretty fun. All right, so here's your practice. Okay, you're going to do the same thing. It says, what's the actual distance between Daytona Beach and Orlando? Use a ruler to measure the map. And then it also says Tampa and Orlando. So let's go ahead. We didn't really do this in the practice. So let's find Daytona and Orlando. So Daytona to Orlando is right here. Okay, and we need to go ahead. I'm going to grab our ruler out here. Okay, let's go ahead and move this to here. Okay, and let's go ahead and shrink this up a little bit, and we're going to line this up. This is sort of a neat way to be able to do this with the ruler. Okay, so we have this distance right here. Okay, that is 1 unit. Okay, so there's our 1 unit right there. And so it's pretty close to the mark. Okay, so 1 unit, let's see what this is. And you can sort of look and estimate here, or we could actually tap the line. So I'm going to go a little bit below, double tap. And then you can see, you can pretty much see if I double tap again, we have 2 units of distance there, okay? So the actual distance is 2 units, okay? And then why don't you try it for Tampa to Orlando, okay? So it's a pretty longer distance from Tampa to Orlando. You already have the 1 unit there, okay? It's pretty close. Let me shrink it up there. Okay, and then you can take your ruler up, first line it up between Tampa and Orlando. Okay, and Orlando's the dot there. Okay, so line up your space, and then all you have to do is start double tapping, and then shift it, double tap it again, and see how many units that one is. Okay, so you can try that one out on your own. Okay, and then calculate if you know the unit rate is 1 unit is 26 miles. Well, from Daytona to Orlando, it's 2 units. So if 1 unit is 26 miles, what's 2 units? Well, that's 2 times 26. So 2 times 26, I don't really have to make a proportion for these easy ones, equals 52 miles. Okay, so that's the actual distance from there. So go ahead and try out number 2 on your own. If you look at 3 and 4, we're finding the actual areas of things. Your scale is 1 inch is 6 feet. So again, those are easy, just multiply by 6ers. But don't forget, you need this to be in feet squared. So you want to make, if it was a test or something, I would write that in right away, almost make my answer spot so I don't mess up. Number 5 and 6, they want you to reproduce the drawings. So I'll get you started with number 5. The current scale is 1 unit is 10 feet. They want you to reproduce it with a scale of 1 unit is 5 feet. So I know that the number's going down, and that can seem like you're making your drawing smaller, but think about it. If we want to reproduce it, the picture is going to be bigger because each box is representing less. Okay, so to have the same image, it's going to be bigger because each unit doesn't represent as much. Okay, so think about what's happening when we have this situation. So the first thing that you want to do is think about, okay, 1, 2, 3, 4, 5. Okay, sorry, this is 5 units, and this is 1, 2, 3, 4 units. Okay, and so what's happening to this? So from 5 times what got me to the 10? Well, 5 times 2 is 10. Okay, so everything is going to be doubling in size. Okay, so it's times 2 and times 2. And so we're going to end up with 10 length. Okay, so let's see what we got here. We'll start on the edge. Remember, make your hard line like that first, then you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then 4 times 2 is 8. So make your straight line first, then you can count 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then you can connect the 2 points. Again, make a straight line, and then you can connect. Okay, and then go ahead and label. So we have 10 units, and we have 8 units. Okay, all right, so there is our drawing. Okay, and it's still the same amount of actual feet. Okay, because in this one, it's a 1 unit equals 5 feet, and in this one, 1 unit equals 10 feet. Okay, so of course it's a smaller drawing. Okay, but still, so think about it. We have 5. This length ends up being 50 feet. For this one, times 5, this length also ends up being 50 feet. So it's the same scale drawing, it's just enlarged. Okay, all right. So you're going to go ahead and do this one. Okay, the drawing uses a scale of 1 unit is 12 inches. Reproduce it with a scale of 1 unit equals 24 inches. Okay, so this one, think about this, is a little bit opposite. Okay, so this one here, every box is 12 inches. This one here, every box is going to be 24 inches. So it's going to end up being a smaller number. Okay, so for this one, you're wondering, well, 24 times what gets me 12? Okay, because we're going smaller. Okay, so think about that one when you're making your new drawing. Okay, all right, your apply is the same that we did before, okay, with calculating the area and the cost per square foot. Okay, so that's something I think you can mess with and play with, and you have lots of workspace room. So go ahead and work on that. Let me know if you need help.